Welcome to EDU World Space.
Let's find the values of x for which this series converges. So that'll be one part of this problem here. Let's call that part 1. And then for those values of x in part 1, we'll go ahead and find the sum. So that'll be the second part of this problem. So for the first part here, let's just rewrite this series. It's actually geometric, but it might not be obvious by the way that it's written. So here I would just write this as e to the x to the n power. Here I'm just using your laws of exponents. You could always rewrite this as a b times c. So if you want, you could always pull out one of the exponents here, and I just chose to pull out the n. So now I can see that this is geometric, and our r is equal to e to the x. So once x is fixed, this is your r value. And we know that geometric, that these will converge if we have the absolute value of r is less than 1. So in this case, this will converge if the absolute value of e to the x was just e to the x, since e is always positive. So the absolute value is always equal to itself. And we need this to be less than 1. So now we have an inequality here that we need to solve for x, because in part 1 we do want the x values. So let's take the natural log of both sides here. So this is, since the log function is increasing, the bigger the input is, then the bigger the log will be. So since 1 is bigger than e to the x, ln of 1 will have to be bigger than ln e to the x. So here on the left side, using the fact that ln and e to the x are inverses, this is just x, and ln of 1 is 0. So that's our answer to part 1. We want x to be a negative number, and then the series will converge. Now we go to part 2, where we actually find the sum of the series, assuming that, of course, x is a negative number. So let's go to part 2 now. Let's save some room here. So for part 2, for a geometric series, we know that the sum equals, you take the first term of the series over 1 minus the r, the common ratio. So in this problem, the first term happens when you plug in n equals 0 there. So plug that in for n, and you get a 1. You get ex, but that's all being raised to the 0 power. So you just get 1, and then 1 minus r, which is just e to the x. That's from our step 1. And that's our final answer. And of course, the sum only is true when we're assuming that x is less than 0, because that's when the series converges. So that's our final answer.